Hi everyone, my name is Tyler, and today we're going to be talking about the Big Data Challenge. Now, there's sort of three parts to this workshop. We're going to start off by just talking about what big data actually is. From there, we're going to go into how specifically to use big data and sort of get you prepared for this specific challenge. And then finally, we're going to move into the actual challenge portion where you will be solving some problems, earning some points, and potentially winning some prizes. But to start us all off, I just wanted to talk about what big data is. So you may think you have some idea of what big data is, or maybe if you're like most people, you feel like you have no idea what big data is at all. You've just heard that word thrown about a lot. Um, Big data is a little bit of a buzzword, but it does have a specific meaning. And what we mean when we say big data is it's data that is just too big to work with on one single computer. So if you can open an Excel spreadsheet, that Excel spreadsheet is probably not big data. But if it's such a big Excel spreadsheet that you can't open it, or a Google Docs spreadsheet or whatever else, that's when it becomes big data, and we have to use special techniques to work with it. And we'll talk about what some of those are. Now, broadly speaking, big data is broken down into two different parts. There's structured data, which is, you can think of this as anything that could be represented as like a table or a database, or like, if you're more familiar with programming, a JSON file. That's all structured data. We also have unstructured data, and that's things like text messages or emails or anything that's just sort of free form and might have interesting things in there as well. We combine all of this together, and between the two of them, we get big data. Now, in this workshop, we're going to be using a specific system for working with big data. The system itself is called HPCC, or High Performance Computing Cluster. It's an open source piece of software that's used for big data. And one of the really cool things about this software is that they have internships that are available to high school students and college students. So no matter where you are or how old you are, they have paid internships that are available to you, and you get to propose your own project. So this is definitely something worth learning. Additionally, there's a lot of companies that hire for people working for big data, but particularly this internship is really unique for a lot of people who go to Code Day. So I would definitely recommend checking out the HPCC systems internship. And if you search for it, you should be able to find something. We also are going to use a specific programming language to talk to this HPCC thing. And the programming language we're using is a thing called ECL. And we'll talk about ECL. You don't need to know anything about it ahead of time. In fact, if you do, I'd be surprised. But we're going to learn about it, and then you're going to be able to use it. Okay, so let's talk about a little bit more about what big data is and how these processing platforms work. Now, these are not things that you actually need to know to do the workshop, but they're interesting and they're useful if you ever want to get a job or an internship. The first of the three things that I want you to remember is the term data lake. And what a data lake is, I like to think of it this way. If you ever have a drawer or like a box or something where you just kind of shove junk in, anything that doesn't have a place, you sort of just you put it in that drawer, and then later on when you're looking for stuff, you just kind of dig through it. That's what I think of a data lake as. A data lake is like a drawer where you just put a bunch of stuff and then you dig through it later and you find the stuff that you need. And it's not super organized, but it is a very large drawer and it is pretty fast to dig through it. That's what a data lake basically is. It's a place where we put all of our data, but there's no specific one format. We just put it in whatever format the data we have. We ideally want it to be infinite storage and extremely fast. Obviously, it's not really going to be infinite, but it's going to be as big as we can make it. So that's where our data lives. And one of the important things to remember is just that it's going to be in whatever format it's in. And when we use it, that's when we're going to actually start to figure out what format we need it to be in. And so that brings us to this really complicated looking diagram, but it's trying to tell us something really simple, which is that we take this data that we've been storing in our drawer, and we do this thing called ETL, extract, transform, load. And so what we do is we take that data and we extract the data that's useful, and then we transform it into a format that is going to be useful to us, and then we load it into the thing where the code can actually run. Now, all this is going to be done for us, but again, really useful thing to know about big data, that's how it works, is this extract, transform, load. The last thing I want you to understand about big data is this idea. The idea that just fundamentally what we're trying to do here is we're trying to divide and conquer. The other term you might hear used for something like this is MapReduce. And basically what we're doing is if, let's say we want to know something about a data set. And to do it on one computer would take us an entire year. And that's just too slow. We don't want to wait a year for our calculation to come back. Well, if we ran that calculation on 365 computers at the same time and somehow broke it up so that they're all working together, then instead of taking one computer 365 years, it would take 365 computers one day. That's the basic idea. This MapReduce or divide and conquer, we take the big data, we break it up into individual parts, and we send the smaller parts to computers in a really clever way. Now, we're not going to talk about how to do this specifically because one of the nice things about this system we're going to use, HPCC, is that it automatically does this for us. So we don't need to actually figure out how to break up the data or break up the calculations. When we ask it to do stuff for us, it will automatically break up that data. So how is this useful? One example that I've been told of is this idea of a smart hard hat. So, a lot of people are injured every year, and we want to find a way to get less people injured. So, what if we put sensors in a hard hat, and it not only can tell, like constantly reading out an accelerometer of basically has it been hit or not, but also things like temperature, the air quality, all sorts of things like that. We could put all of that together into one big data set. And then we could use big data to figure out how likely people are to get hurt or what conditions are leading to the most people getting hurt. So we could even do something like real time deciding whether or not we need to call an ambulance or whether someone's going to be okay. All right, so now we're going to get into the challenge part of the big data challenge. I'm going to explain how this all works. Now there's two websites you're going to need to register for. The first one is play-data-challenge.codeday.org. That's play-data-challenge.codeday.org. And I'm going to give everyone about 30 seconds to go ahead and register for this right now. So go ahead and open this up in your web browser, register for an account on this website. You don't need to have a specific email or password. It isn't really going to matter because you're only ever going to log into this once. But make sure your username is something that represents you so we can figure out who you are if you won. So go ahead and register for this now. I'll give you about 30 seconds. All right, so hopefully everyone's gotten registered for that first thing, or at least you're in the process of it. Once you've registered, you'll see a screen that looks like this. You actually won't see it just yet because the challenge hasn't started, but once the challenge does start, you'll see a screen that looks like this. What you will see for right now, if you've done everything correctly, is you'll get an error that says 403 forbidden. The challenge hasn't started yet. So once the challenge does start, you would see something that looks like this. Now on the left-hand side here, we have a list of challenges. And on the right-hand side, when you click on one of them, it will open up that specific challenge. You can see that these challenges are sorted into easy, intermediate, and advanced in this case. So they go from easy to hard, and we've broken them up. The other thing to know about these challenges is that each of them has a number in parentheses next to it. That number is how many points the challenge is worth. This is not like a test in school where you need to solve every single problem. Your goal is to get the most points that you can in the time period. So if you're a really advanced, expert level programmer, go ahead and start on the more difficult problems that are worth more points, the ones in the advanced section. But if you're totally new to this, Start on the easier problems because it doesn't matter if you get all of the problems done. It just matters that you get the most points. Also, if there's a problem that you don't know how to solve, just skip it. I'm not even going to say that thing that teachers always say, which is skip it and come back to it. Just skip it. You're not going to be able to solve every problem. No one has ever solved every problem in this challenge. The important thing is that you get as many points as possible because the points are what determine the winner. And again, those points are the number in parentheses. Now, after you click on a problem, you'll see on the right-hand side, it opens up this window with the details of the problem. Every single one of these challenges is also going to have a link to a preloaded data set. Now, when you click on this link, it's going to open up an editor where you can write code online. All of the data is already downloaded. You don't have to do anything. You just write the code and you click run. Once you think you've found out the answer to a problem, each one of the problems is going to ask you a question. And once you think you know the answer, what you're going to do is paste it down here in this box. And for some reason, this box says flag. It's because it's called a capture the flag contest. That's what this type of challenge is called. But this is where you're going to put your answer, and then you'll hit submit. And it'll take a second, and it'll tell you if you're right. And if you're right, you get the points. Now, this link to the preloaded data set, you only need to open this once because every single challenge uses every single question in this challenge uses the same data set. Once you click on that link, it's going to open up this web page, ide.hpccsystems.com, and it's going to open up all the code, but you are going to need to have an account. So just to make sure that everyone is on equal footing, I'm going to pause here and let people register for an account on this. And I'll give you about a minute. This one, you will have to confirm your email address. So make sure you use a real valid email address to register for this. So I'll give you about a minute now to go ahead and register for this. And again, this is a separate link from the other thing you registered for. You do need to register for both of them. So I'll pause here for about a minute and let you go ahead and register for this. Hopefully everyone has been able to register for that. So we'll go ahead and move on now. Now, if you've registered for that and you're logged in, when you go back to a question and you click on this link to a preloaded data set, it's going to open a new tab that looks something like this. In the left-hand side, we see a group of files. On the right-hand side, there's two things. There's going to be this text down here, which is where you write your code. And above it is going to be a thing where you see the output of your code that you write. So all you'll need to do to get this working is write the code, click run, and then see the result. Now, we'll need to figure out what code to write, of course, but you don't have to download anything. You don't have to import any data set or anything like that. It's all already included in here. All you'll need to do is write that code and click run. Now, one thing I want to point out, right here, if you get an error that says that you haven't selected a target, right here, you can just click this drop down right next to the run button and choose one of the options there. But once you're ready, you'll write your code, you'll go ahead and hit run, and it'll show you your result up here. Or if there's an error, you can hover over the line that's highlighted to see what the problem is. Okay, so knowing that we're going to write this code in here, what sort of code do we write? Well, again, we're going to be using this programming language called ECL. And the one thing that I want you to take away from this presentation is just remembering that there are slides for things. This is an open book test. When you actually go to the challenge, you'll see there on the very top, there's a thing that says README. And if you click on README, there's a link to this presentation. So you just click on that link, it'll open it in a new tab, and you'll be able to get to this exact presentation. Now, the important thing, the reason that I say that that's important is because I'm not expecting you to remember everything about this ECL programming language right from the get-go. What I'm expecting you to do is to figure out how it works by referring back to this presentation. And most of the easy problems are only going to require 1 or 2 lines of code at most. And most of it is going to be more or less directly from one of these slides. So don't take notes on this presentation unless you really, really want to, but definitely don't take detailed notes. Just remember that there are slides for things, and then you'll be able to go back and find out which slide they're on once the challenge starts. Okay, so let's get into ECL. Just to start off with, if you are a programmer, if you've been writing code before, go ahead and check out this slide. It tells you some information about how this compares to other programming languages. If you're new to programming, you probably don't need to know any of this, but you can come back to it if you want to know. Okay, here's another thing that you don't really need to know for the challenge, but is good to know in general. So there's basically a data set is a physical file somewhere on this cluster, and we basically tell it what the columns mean. Now, you don't need to do this for this challenge. It's already been done for you. When you click on that link to the preloaded data set, it has already been done. So here's an example of how you would make your own, but again, you don't need to do this. But if you ever want to make your own and you want to do your own data analysis, you can come back to this slide. Now, here are where we start getting into things that are really, really valuable. We have this function called output, and that is how we tell it what result we want to see. You can only output one thing at a time. Each time you hit run, you can only output one thing. So if you take a look here, here's how we output something. Now, there's a thing called named. Right here, named. That's pretty much optional for this situation. It becomes more useful if you did want to output multiple things or output a data visualization, but you can ignore it in most cases and just put output and something there. If we want to limit the number of records we return, we wrap it in this chosen begin parenthesis end parenthesis, and we say it how many we want to choose. Okay, if we want to sort things, here is how we sort them. So you can see we sort by, in this case, we're saying we're sorting the salary average data set by job. And then we just output it. And we could combine this into one line if you wanted. If we want to output something, but let's say we want to filter, right? So we want to just output for people who live in the city of Tampa. Here's how we do that. We take our data set, we put a parenthesis after it. We say column is equal to, whatever, or is not equal to, or is greater than, et cetera, et cetera. If you need to do math, here's the slide with all the math information. So if you do need to do any math, you need to count something, you need to find the maximum of a column or the minimum of a column. Here's how you do that. If you wanted to add everything together from 2 different columns, you can actually add 2 columns together and then sum up the result of each of those sums. If you need to round things, here's how you round them. And if you need to truncate something, which means basically round down, always round down. That's what that means. You can also average things, average a certain column. So if you need to do any math things, and some of the questions will ask you to do math things, come back to this slide. Correlation. So when 2 data sets are correlated, they have, a high number, a number that gets closer to 1, more positive number. If data sets are not correlated, they have a more negative number, so closer to -1. Now, what does that mean when we say that they're correlated or they're not correlated, right? If something is correlated, it's like saying, let's say a direct correlation would be like if the temperature goes up, my sweat production goes up. That's a direct correlation. That is something that would be closer to +1. The more true that relation is, the more direct that relation is, the more it's going to approach 1. Let's say that as the temperature goes up, my amount of shivering goes down. That's an inverse correlation, a negative correlation. And that is going to be closer to -1, a more negative number. If we say as the temperature goes up, the price of wheat, price of wheat might actually change. As the temperature goes up, the price of graphics cards changes. Price of graphics cards is probably not related at all, either positively or negatively, to the temperature. So that is going to be no correlation at all. If we want to know how correlated things are, here's the way we do that. We say correlation, we give it the data set, and we say which two columns we want to know if they're correlated. And it'll give us those numbers. All right, so now we're getting into the more intermediate and advanced things. If you're a beginner, you probably won't need to know most of this, or you don't need to know at least how it works. One thing that you will see sometimes is that you'll see modules or things that are sort of before a dot. So sometimes you'll see like my file dot my thing, my data set, or whatever else. It's a module. It doesn't really matter. Most of the time, if you're a beginner, you'll be copying and pasting this. But if you're more advanced, you might want to know this. Again, if you're more advanced and you want to know about variable scope, if you know what the word variable scope means and you want to know, here's the slide for it. If you don't know what this means, you can ignore it. You won't need it for the beginner problems. One thing, again, here's what you'll see is like this something dot something else. You will see that in the code. It doesn't matter what it's doing. Just know that you need that something dot something else whenever you're loading from a different file. Okay, so transforms and projects, again, advanced thing. If you're a beginner, you can totally tune me out right now. Transform is something that basically is a function that's applied to every record in a data set. And project is the way that we apply that function to every record in the data set. So here's how you would use those. Here's a code sample. Again, if you're an advanced programmer, take a look at the slide if you're doing the advanced problems on how to do a transform and a project. Here's another way to do it that's inline, so a little bit more compact. Okay, if you need to make a temporary data set and do something like group by the things that happen on a certain day or something. Here's how you do that. So if you're an advanced person, you're doing anything involving like grouping or making a new data set, here's how we do that. Joins. This is when we have two different data sets and we have some property that's in common and we want to join the two of them. Again, only for advanced people. So if we have, for example, a list of employees and their employee ID and their name, and then we have a different data set of employee ID and department, and we want to know name and department, we can join those two together using these join functions. And there's a few different ways of doing this. There's inner joins, outer joins, left, right, all sorts of joins. Basically, what we're saying is these are different ways of dealing with when something exists in one data set but does not exist in the other data set. If you're advanced, again, this is a slide for you, but most people won't need this. And finally, there are no questions that ask this, but it's still fun. Some people like doing this. If you want to visualize anything, here's how you do visualizations. You can make these cool visualizations. It's not in the challenge, but some people like to play around with this afterward and try to do cool stuff with it. So you can do that. All right, so with that in mind, we are just about ready to start the Big Data Challenge. Again, to get to the Big Data Challenge, you're going to want to go to, it's right here, play-data-challenge.codeday.org, register for an account, and then at exactly 1/2 the hour, if you refresh that page, you will see the Big Data Challenge will start. So at exactly 1/2 the hour, go ahead and open up this page, refresh the page as long as you're logged in, and you'll see the challenges. So that should be in just a few seconds here. And again, remember, The challenge is only until the top of the hour, the end of this hour. So you have 30 minutes, and whoever gets the most points wins. So with that in mind, go ahead and have at it. Good luck with the challenge, and we're excited to see how well you do.